is next type is difference of sets. Difference of set means the difference of two sets A and B is the set of those elements of A which are not in B. If we want to find out the A minus B means A difference B, so that times all the elements of A but not in B, it's denoted by the difference between two sets, which is denoted by A minus B, the difference between A minus B. Okay, the syntax for the given set is A minus B equals to which contains the X elements such that X belongs to A and X not belongs to B. Okay, so only which contains in A set means starting set, okay, but not in second set, those elements which are the member of A difference B. Okay, so for example, suppose next second, this is the syntax for A minus B, but B minus A, what is the syntax for B minus A? Which the B minus A set, which B minus A means the difference between B minus A which contains the X elements such that X belongs to B first set and X not belongs to A, X not belongs to second set. So those are the such types of elements which are the members of a difference between B minus A. For example, suppose a set which contains 4, 5, 6, 7, 8, 9 elements, okay, and B set which contains 2, 3, 5, 7, and here to find out the A minus B, the difference between A minus B, A difference B. Okay, so here the first formula is, here we need to find out only all the elements of A but not in B. Okay, 4 elements which are not in B, so write down here 4. Next, 5 elements of A set which are also belongs to B set, so discard the elements. Next, 6 elements which are in A set but not in B, so write down in different set. Okay, next 7 is also members of a B set. Next member of a set is 8 which are belongs to A set but not belongs to B set, that means we consider in different set. Okay, next 9 number which are in A set but not in belongs to B set, so write down here 9. So this is the difference between A minus B. Okay, next we can also find next B minus A. B minus A equals to, so at the time when we find the B minus A, at that time we consider the elements of B at the starting. Okay, because B start here. Okay, so 2 which is the members of a B but not in A, so write down 2. 3 which is a member of B but not in A, so write down 3. 5 which is a member of B and which is also belongs to A set, so discard the element. 7 which is a member of belongs to B set and also belongs to A set, discard the elements. This is a B minus B difference A set. And one thing is that A minus B always not equals to B minus A. Okay, not equivalent set. Next, there are some important points. It may be noted that A minus B not equals to B minus A. Difference of set is not commutative. Difference between set are not commutative. Commutative is a law, algebraic law. We will see in next video. Okay, so here A minus A equals to A minus A equals to 5. Okay, means null. Okay, how it is possible? Okay, for example, suppose here we have considered A set which contains 1, 2 elements. Okay, and here the difference between same set. Here ask for difference between same set. A minus A means 1 2 minus 1 2. Okay, so here A minus A equals to first elements of A set which also belongs to A set, and second elements of 2 is also belongs to second set. So this is a null, or we can define as a null. So A minus A is always null set. Okay, next is A minus phi. Next is A minus null set is equals to A set, is always A set, because suppose A set which contains 1 2 elements and phi set is a null set, means suppose phi equals to open bracket curly bracket. Okay, so A minus phi is equals to A minus phi equals to all the elements of A but not in B, means 1 belongs to A set but not in belongs to phi set, means write down here 1. So 2 which are belongs to A set but not in phi empty set 2. So this is a set, so that means A minus phi is always equals to A set. Okay, same thing is phi minus A is always phi. Phi minus A is equals to phi, is equals to phi, because suppose A set which contains 1 2 elements and phi set which contains null elements, but here ask phi minus A, ask for phi minus A. The syntax for phi minus A equals to null set minus A set. A set means 1 2. This is the syntax for a phi minus A. So because here we consider the all first elements is phi, so here contain null, there is no elements in here. Okay, so that time this is a empty, this is a empty, because we consider in difference only starting elements members, we consider only starting member element starting sets members. Okay, but here there is no elements or numbers in phi set because it is a null, so it is always null or phi. Okay, so by same way we can find out the A minus B. A minus B is equals to A if A intersection B equals to phi. Suppose A minus B equals to A if the condition A intersection B is equals to phi. Okay, if this condition is satisfied, so that time this A minus B is always A. Okay, suppose A elements which contains 1 element and B set which contains 2 elements, only single elements considered in both set 1 and 2. Okay, so A intersection B equals to null, because there is no common elements A and B, it is a null set. Okay, so this condition is satisfied. Now we are going to find out the A minus B equals to, suppose first set is A, so write down first set minus second set is B 2. Okay, so here to find the we consider first set element 1 which are belongs to A set, but 1 which are not belongs to B set. So that means A minus B equals to 1. Okay, 1, and A set we have only 1 elements, so just only check for one elements, and this is answer, and the 1 element which is a member of A set, so this is A. So A minus B is equals to A always if A intersection B equals to empty set. Okay, so same thing, A minus A complement is always A set, you can study at home. Next point is symmetric difference. The symmetric difference of two sets A and B is denoted by this symbol, A symmetric difference of B, by using this notation. This is the notation of a symmetric difference. The main syntax for how to find out the symmetric difference between two sets is A symmetric difference B equals to, in braces which contain element x such that this vertical line which denoted to read as such that x belongs to A minus B, or x belongs to B minus A, or B minus A. That means we can find A symmetric difference, we can return A symmetric difference B as A minus B union B minus A. This is a union of A minus B and B minus A is a symmetric difference. Okay. So next, for example, suppose A set which contains which contains 4, 5, 6, 7, 8, 9. 8, 9. Okay, and second set B set which contains 2, 3, 5, 7. Okay, now here we are going to find out the A symmetric difference B. Before the find the A symmetric difference B, we need to find out the first A minus B, and then B minus A, and then union of both sets. Okay, so first A minus B. To find out the A minus B equals to all the elements of A but not in B. Okay, means 4 elements of A set which are not belongs to B set, means 4, 5 which are belongs to next element 5 which are belongs to B set, so discard. Second 6 element which are not belongs to B set, write on 6. 7 which are also belongs to B set. 8 which are not belongs to B set, and 9 which are not belongs to B set. So this is A minus B. Next, second element B minus A. Okay, B minus A means consider the first elements of a B set. 2 B set elements 2 which are not belongs to A set, so write down 2. 3 which are not belongs to A set, 3. 5 which are belongs to A set, and set B elements 7 which are belongs to A set, so you discard all the elements 5 and 7, and this is a B set. And here the main formula for it to find out the symmetric difference of a two set B equals to A minus B union B minus A. Okay, so now here to find out the symmetric difference of a two set. How to find out the union symmetric difference of two set? Union of a both sets, different set. Okay, so now here equals to A symmetric difference B equals to union means all the elements of first set and second set, and common element considered only one time. Okay, so here two elements in B set, 3 which is also B set. Next element in A minus B, 4, 6, 8, 9. So this is a symmetric difference set. Okay, we already solved here. This is the answer of a symmetric difference B. Okay, next is there are some important points of a symmetric difference. A symmetric difference A symmetric difference A is always phi, because A minus A, here we need to find out the A minus A union A minus A. Here to find out the A minus A union A minus A. So this is always 5, union is always 5. So answer of both set is 5. So that means A semi-difference A is always 5. Second, A semi-difference B 5, sorry, A semi-difference phi equals to A always. A semi-difference phi equals to A, because A minus phi first set union phi minus A. Okay, so A minus phi is always A set because all the elements are A, but not in second set. Second set is null set, so all the elements of A set union pi, all the elements of pi but not in A, and pi set is null, so this is null. And A union pi is always all the elements of A, and pi set contains 0, means that is A. So A semi-difference pi is always A. Okay, next point, A semi-difference U. A semi-difference U is always A complement. A symmetric difference U is always A complement. Okay, so here we need to find out two sets, A minus U union universal set minus A. Okay, so A minus U, all the elements of A but not in U, but not in U. Kaila's answer pi. The answer is pi, because every elements of A which are the member of a universal set, every members of A which are the member of universal set union U minus A means all the elements of U but not in A, that means A complement. All the elements of U but not in A, that means A complement. So phi null set union A complement is always A complement. So A semi-difference U is always A complement. Okay, and A semi-difference A complement, A symmetric difference A complement is equals to universal set, because suppose A minus A complement union A complement minus A set. Okay, so here A minus A complement means all the elements A, and here both sets A and A complement, both sets is not always not equal. There are different elements A set and A complement. Okay, so this is A set union, and here all the elements of A complement not in A, total different elements A complement contains, so here A complement. Okay, and union of A union A complement is always U, because A complement is contain all the elements of U but not in A, and A set this is set contain A elements, total all the elements of A, and here all the A complement elements, that means this is a universal set. So A complement, A semi-difference A complement is always universal set. Okay, this is the main symbol, main formula for a to calculate the, to determine the A symmetry B is equals to A union B minus A intersection B. Suppose here A symmetric difference C, so that times we need to write down A minus to find out A minus B union, sorry, A minus C, sorry, A minus C union C minus A. By doing this syntax we can solve the semi-difference problem. Okay, thank you all of you, and if any query you can ask me, ask me on a WhatsApp group, and when you watch this video, so that time you write down your roll number and name in comments. Okay, this is the this is for a attendance, your attendance. Okay, thank you all of you.